so now let's do some more practice for our hydrates. So the first problem says, what is the formula of magnesium sulfate heptahydrate? All right, so when I see that it's got this hydrate in the name, then I have to remember what the definition of my hydrates are. So my hydrates are going to be some ionic compound, then a dot, and then the number of my waters. That's the basic general formula for a hydrate. So this is going to tell me the number of my waters. This part is my ionic compound. That's how it always is going to be. The ionic compound and then the number of your hydrates. All right, so to write the formula, let's first do the ionic compound. So we see magnesium sulfate. So we need to know what magnesium is. We need to know the symbol and the charge. So we go to my periodic table and I find magnesium, Mg, right here. And it's in column 2, so it's a +2. So this is magnesium +2. Then the next part is I need to look at the anion. This is an 8. It says sulfate. So if it's an 8, if it's an 8, then that's telling me that it's a polyatomic. Because remember, polyatomic ions end in 8 and ite, and then just the non-metal is going to end in IDE. So then I have to figure out, well, what's sulfate? So we have all of those on our polyatomic ion chart. So we look it up, and it's SO4 2-. So remember, we need to do our cross down. So I would get Mg2SO4, because that stays together, because that's the polyatomic ion, 2. Can I reduce the 2's? Yes. So that gives me MgSO4. Then I could do my check. I have 1 Mg at a +2, I have 1 SO4 at a -2, +2, -2 cancels. So we're good for that part. So MgSO4, and you can leave it in parentheses if you want, but it's a hydrate, so I have to add my dot. Then I need to know, well, how many waters, because I know it's going to have waters, but how many? So hepta. So if I go back, I say, well, what is hepta? Hepta is 7. So this is telling me .7 waters, and that would be my formula. So MgSO4.7H2O. All right, next is, what is the name of NiCl2 6H2Os? Okay, so I see the dot, so I'm like, oh, this is a hydrate, so here's my hydrate, here's my ionic compound, because this is going to be the ionic compound. This is telling me the number of my waters, so this is my hydrate. Okay, so let's name the ionic compound first. So the first thing I see, I have Ni and I have Cl, so there's no polyatomic ions. I need to figure out what Ni is, so I go to the periodic table, and I look and I find Ni right here. It's a transition metal, so I know it's a metal. I already know it's ionic because it has to be ionic if it's with a hydrate. But since it's a transition metal, that tells me that I have to figure out its charge. I have to do the Roman numerals. So I know that this guy, this Ni, is a metal, and he's variant. So I got to figure out his charge. So he's attached with a chlorine. So same like we did before. So chlorine right here is a -1. So I know that chlorine is a -1. There's 2 chlorines, so that's going to give me a -2. Here, let me write that a little bit better. So since there's 2 chlorines, that's going to give me a total of a -2 on that side. So that means that my Ni, if this is a -2, this has to be a +2 because there's only 1 Ni. All right, so then I need to figure out, well, what is Ni? So Ni is nickel, so we say nickel 2, put the charge. And then chlorine becomes chloride because it's a non-metal, and so it's got to end in IDE. Then 6 is, oops, meant to do this. 6 suffix's prefix is hexa. So then we say hexahydrate. Okay? So that's for hydrates, going from the name to the formula, or going from the formula to the name. So that's everything for ionic. So the next lecture, we're going to start talking about covalent bonding and molecular compounds.